Hey, I wanted to make this video for any absent students for the 8-5 Part 2 practice problems. So your 7 steps are up here. We're still adding and subtracting rational expressions, meaning expressions that look like fractions, okay? So we've got fractions with x's in them. So step 1, always factor your denominators. That first denominator does not factor. How about I do this? Anything that does not factor today, I'll put in yellow. The second denominator does factor, and the third denominator does factor. I'm going to try to do some colors with you, okay? So I'm asking that you please pause the video and factor the orange and the blue. Next, so the blue one, it should be written variable first, so the negative x and then the positive 2. And then you should notice a GCF of -1. And when you pull that -1 out, it becomes a positive x minus a 2. So the blue will factor to a -1 with an x minus 2. But I have taught you that if you ever have a GCF of -1, let's go ahead and kind of give that some emphasis. You are allowed to change this sign right here. So this sign is going to, like the GCF and the negative sign are almost going to kind of cancel each other out. So that is actually going to change to a positive sign, and now you can ignore this. I am hoping that you tried to factor the orange on your own. There's nothing I can do to force you to do that, obviously, but you should have factored this. Things that multiply to -10 and add to 3 will be +5 and -2. All right. So I'm going to re-highlight the denominators. So this is the new blue denominator. This is the new orange denominator. So your common denominator is made up of your first denominator, which is x plus 5. I'll highlight that in yellow if you need it. The other denominator that makes it up is x minus 2. And because the orange denominator is x plus 5 and x minus 2, you do not need to add anything else to the common denominator. It's now time to see what was missing. So I'm going to do this so we have a good visual of each fraction. And we're going to figure out what's not the same. So remember, our common denominator is x plus 5 and our common denominator is x minus 2. So those two items, those two factors. So where my star is, all it has is x plus 5, so it needs the x minus 2. Where my star is, it has the x minus 2, but it needs the x plus 5. So now we're the same as we were yet on Friday, or whatever day was before this, if you're watching this sometime in the future. The orange is perfect. The orange needs nothing. It's good to go. So I will walk you through like the bring it over step, but then you need to distribute, combine, refactor, and cancel. So the first, take a look please where my star is now. The first fraction is 3x plus 5, parentheses, and x minus 2 in parentheses. The next one, where my star is now, is a plus sign. Don't forget that plus sign. An x plus 5 and an x plus 1. The next one, please take a look where my star is. Especially my students who tend to move quickly, where there's not a lot of pause and consideration, miss this because it's a minus sign. And then the 4x squared minus 3x minus 1. Remember, all of this has this common denominator. It's one huge fraction at this point. Now, I walked you through the factoring. I walked you through like what was missing. I walked you on bringing stuff over. What I'm going to have you do on your own to finish this problem, you need to distribute 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3. You will get a new fraction. The denominator will stay the same. You're going to need to combine that. So let's see, I'll make this a little bit bigger. Okay, so you're going to have like one really large numerator. Okay, this will be where you distribute. We'll duplicate that because you're going to need to combine. Let's hit duplicate. I know I'm taking a little while, but hopefully you're keeping up all right. Shrink that down. Okay, so you will, after you distribute, you are going to need to combine. Watch your positives and negatives. So this is where you're going to combine. After you combine, you're going to need to, ooh, that's fun. Okay, I just really want that to shrink down. There we go. After you combine, you are going to need to try to factor it. And if you can factor it, you will need to then cancel. I'll leave the rest up to you for this problem. Your restricted values, FYI, will come from your common denominator of x plus 5 being 0 and x minus 2 being 0, and you'll have to solve those. Okay, the next problem. I'm hoping you know that these are not only the same, but that they do factor. I cannot force your hand, but I certainly hope that you're pausing the video and trying to figure out what multiplies to 12 and adds to 7. These are fast factoring. So again, I'm asking you pause the video and that you try to fast factor these. You should have gotten x plus 3 and x plus 4. Please notice I did not factor the numerators. That's not part of the steps. Because your denominators are the same, the common denominator is x plus 3 and x plus 4. I'm going to put that in this one over here. And now you have to do that like, what is it missing step? I'm hoping you know, though, since they were both the same, this isn't missing anything because it has the x plus 3 and the x plus 4. And therefore, this is also not missing anything. The next thing over here, again, that's not missing anything. So you're at the bring it over step. And just like last time, I'm going to have you guys kind of finish on your own after I help you bring stuff over. So I'm going to bring over x squared minus 2x plus 3. I'm going to bring over the minus sign and the x squared minus 4x minus 5. I do realize I write very quickly, so I'm going to make sure you know where I got that from. Here's the x squared minus 2x plus 3. Here's the minus sign and the x squared minus 4x minus 5. All right, I'm going to leave you guys to do these steps. Hopefully you did in this first problem as well. You are going to need to distribute. After you distribute, you will need to combine. After you combine, you will need to try to factor. And after you try to factor, you will need to cancel. So I'm just going to fix the common denominator to be x plus 3 and x plus 4. And then you will be responsible for finishing that. The only thing I'm going to tell you about, the restricted values are the same. They're x plus 3 equals 0, x plus 4 equals 0, and you do need to finish and solve those. Number 3. Just wanted to see how much we had. Number 3, looking at these, you should notice that they're not the same. However, this does factor, and so does this. I would ask that you pause the video and try factoring them. They're both GCF problems. Again, I can't force you to factor, but just know if you're not factoring on your own now, you're probably not going to be able to factor on the test by yourself. So the GCF on this one, it appears to be an ACB problem, but it's not. The GCF is just x, so you get x minus 5. And the GCF on the next one is 5, so you get x minus 5 again. Now, your common denominator can be difficult. The first denominator is, let's see. So the first denominator brings over an x and an x minus 5. Then the second denominator brings over what's different, so just the 5. You're not going to bring over another x minus 5. So your common denominator, let's make it look pretty, is a 5, an x, and an x minus 5. It just looks better written that way. I mean, I guess you could write it in order how we did, but that just looks kind of silly. Okay, now we do the what's missing step, okay? So let's see, we have this one here and this one here. And we like play spot the difference, right? So I see the x and the x minus 5. That means that this one's missing a 5. Some students get weird. They're like, it already has a 5. It's like, nope, it doesn't matter. It's what is it missing from the denominator. Give it top and bottom. This second fraction has a 5 and an x minus 5. So here I can change colors. It has a 5 and an x minus 5. Therefore, it's missing an x. I'm going to do the same thing. Bring you through the next step. So the first thing I bring over from here is a 5 times a 5. Yes, I know that's 25. And the second thing is a minus with an x times an x. So you are going to go ahead and right here, it's small enough, you distribute. In other words, you get 25 minus x squared. Please write this variable first. After you write it variable first, I'm telling you that it factors. I will give you the hint that it factors with the GCF and difference of perfect squares. So there's your hint. And then you should be able to cancel, after you're done with that, if you can't, you should be able to cancel and rewrite your final answer. Don't forget that each time this comes over. Right, so it will come over here when you make it variable first. It will come over here once you start factoring it. And then once you cancel and rewrite, hopefully you'll be able to see some stuff canceling and you can rewrite your final answer. So let's talk about the points of discontinuity or the restricted values. It comes from your common denominator over here. So these 3 items. I'm recording a lesson, just so you know. You're more than welcome to be part of it. I just didn't want to make you.
Oh, it is part of the lesson right now?
It is right now.
Hi.
Hi.
All good after?
Absolutely, yes.
Awesome.
Thank you. You?
Yeah,
Good.
great. I'm a tired bean, but that's...
I can't imagine.
Hear that lesson? I'm a tired bean.
That's fair.
Yep, not a coffee bean today.
They're setting all their denominators equal to, or yeah, their denominator factors equal to 0 in solving.
That's fun.
So x equals 0 is already solved. X minus 5, make sure you guys add 5, and then 5 equals 0 doesn't make any sense, so cross it off.
You hear that, all you coffee beans?
Coffee
Math is cool and
Math
fun.
is cool and fun, thank you.
Oh, yeah.
I don't know how much of this I'm going to do for them. Okay.
Well, you enjoy that.
I will, thanks. Thanks for checking in.
Yep, absolutely.
All right, number 4, test out those factoring skills. Both this blue and this orange will factor. Yeah, you should 100% pause this video and factor them yourself. They're no GCFs, but they are ACBs. You're looking to get 4 and 5 on this one, so 1 and 4. You're looking to get... I am doing this fast because it is my expectation that you should be able to factor pretty quickly, or at least understand what I'm writing down, okay? All right, again, but hopefully you have this whole video paused because you should be factoring all on your own. Let's see, what would that be then? All right, it is obviously my hope that you factored those on your own. Just remember, if you can't factor them on your own now and you're just taking my answers, you'll not be able to complete the test well. And I definitely don't want you to have to go into a guessing game type of situation. All right, so we have 2x plus 1. We have x plus 2. And we have x plus 1. So I factored them for you. I hope you know that you're going to play the spot the difference. So I'll put your common denominator over here. I'm not going to do too much in this problem. Hopefully you've gotten warmed up. And then you're going to see what's missing. So like this one and this one is missing the x plus 1. This one and this one is missing the x plus 2. Then you're going to do the carry it over step with your signs, distribute, combine, factor, cancel. I'm going to leave you all on your own on number 5. Hopefully I've given you enough to kind of get going. Those ones are pretty similar. Same thing with number 6. Please watch out. There is a GCF right here that kids don't see. And this one is difference of perfect squares when you factor it. And now for number 7 and number 8, I will at least get you started, okay? So when we see this is your first time that you're seeing complex fractions. except obviously I did them on the notes. You need to treat the numerator as its own problem. So I'll use this ticker tape to cover up the bottom. So it's like we don't even see it then. And we have to make this into one big fraction. It's my hope that you know the only denominator is n plus 5. And so this one's technically over 1. So this needs an n plus 5 here. And this is good. So you're going to bring over your n plus 5, and your minus 4n. Now, without giving you too much, because I want to make sure that this is your authentic work, carry over your n plus 5. You're going to distribute. Okay, if you need to see your distribution arcs, it'll be 1 and 2. All right, you know what? I'll give you that. It'll be n squared plus 5n minus 4n, excuse me. You are going to need to combine those things. And after you combine them, you're going to need to factor. P.S. There is a GCF on this one. Now what you do is, and then you leave that alone. Okay, so you're going to have something over something. You know what I'm going to do? I'm going to draw, you're going to have a star over a smiley face. Because I want you to do that part. You can definitely combine and factor there. There's a GCF. Okay, now what we do is we pretend we don't see the top. Okay, so let me put that ticker tape on. And we do the denominator. So this one has a common denominator of n plus 5 and n minus 5, because they're both different. This one here needs an n minus 5. I think I have to just draw arrows because I'm not sure what will happen if I don't. This one needs an n plus 5. And then you bring stuff over. So you'll bring over your first one with an n minus 5, a plus 1 with an n plus 5. Take a look at my arrows. And you're going to follow the same steps. You'll distribute, which I'll help you with. 1n minus 5 plus 1n plus 5. Denominator carries over. Pause the video. If you're not keeping up, pause the video. Don't desperately try to copy because you're going to get lost. All right, I'll just like sit here awkwardly for 10 seconds. Make sure you're making the connections you need to. All right. I truly, truly, truly hope you're doing this the authentic way. Like, you know, get your questions answered. Try to find what you're missing. Okay, the next thing you're going to do is you're going to combine, right? Okay, so whatever you get, go ahead and combine here. Hopefully you should be able to do that. Then, if possible, which it's not, you would try to, let's say, come on, you factor. This one will not. So after you combine, you're going to be done. So what you're going to have now is you're going to have, what shapes? I'm going to get rid of that. You're going to combine, and let's just say once you do that, it won't factor, by the way. You'll get, use some more shapes. You'll get a sun over a, I don't even know what shape I want to do. Over a bullseye. Okay. Divide. So now what you do is you take your numerator and you divide by your denominator. In other words, you'll take your numerator and you'll multiply by flipping your denominator. Okay? So whatever that means, guys, you're going to have whatever your star was. You see your star up here, right? You're going to have star over smiley face times bullseye over sun. And then you're going to multiply and cancel. So like, you know, if you can cross cancel. And then what you have left, put as your final answer. Okay, put it as your final answer once you're done. The points of discontinuity is anything that was in the denominator, is in the denominator, it happens to be flipped into the denominator. So from the numerator, definitely n plus 5. From the denominator, add in the n minus 5. And then anything from when you did the flipping, anything else that happened to ever be in the denominator also gets set equal to 0. Okay, number 8. Right, again, we do this little ticker tape thing, right? So we don't see your denominator at all. The common denominator up here is a P with a Q. This one needs a Q. This one needs a P. This one needs a Q. This one needs a P. So when you bring it over, you get 1Q plus 1P. I hope you know that doesn't combine, it doesn't distribute, and it doesn't factor, so that one's done. Now we kind of ticker tape that one so we don't see it, right? Oh, that was a little much. Let me just do that. Down here, your common denominator is a P squared and a Q squared. Let me see if I can erase that ticker tape. This one needs a Q squared. This one needs a P squared. So you get Q squared, 1Q squared minus 1P squared. Nothing to distribute, but what I do hope you recognize, it should be, you should be at the step where you're like, oh, that's difference of perfect squares. So you guys, I'm not going to do it for you. You're going to factor here. Okay. And then remember, take a look at my purple circle. You'll do my purple circle times the flip of this one. Cross cancel if possible, and then multiply straight across for your final answer. Hope that was helpful to get your homework started and completed.